Okay, we are going on. So the next type of reactions is combustion reactions. As I already mentioned, it's a fancy word for burning, right? So we have something like fuel, and the fuel can be burned, and water and carbon dioxide is being formed, and of course the kind of amount of energy, right? That's why we use these combustion reactions for heating, for cooking, for whatever, right? The next one is single replacement reactions, and one element replaces another element. So we have element and a compound, and element replace uh, one element in the compound, right? So usually it's in ionic compound, one element can be replaced by another one, and you will see it after all. So, the new terminology for you here is dissociation. Dissociation here, dissociation is the breaking up of the compounds into cation and anion, and usually it happens with ionic compounds, and also acids can be doing dissociation in water solution on or when they are melted, right? So from a solid to a liquid state. Dissociation. So, for example, when we put a certain amount of table salt, sodium chloride, into water, sodium chloride immediately begins breaking up onto into sodium cation and chloride anion. So, why it's happening? This is just the first very simple explanation for this process. For those of you who are going to take in other classes, you will be talk about dissociation more. But for now, it's just the process in which water is involved very much, and you know the water is polar. Uh, Molecules of water are very polar. That's why they are like breaking down the compound on small pieces, right? Like predator fishes, right? So these processes being called hydration, in which an ion is surrounded by water molecules arranged in a specific manner, right? And pay attention, guys. So we know that on oxygen there is delta negative charge, right? Uh, and sodium is positively charged. That's why water oriented around this sodium cation with their oxygen toward sodium cation, right? But when water surrounding chloride anion, it turns different way with delta positively charged hydrogen. So this is dissociation process, is the breaking up of the compound into cation and anion. For example, let me give you some example. Let's take another similar something, right? Like sodium or potassium bromide, right? Ionic compound too. And in water, it breaks up into cation of potassium and anion, bromide anion. And you can ask me, how do I know what charges it will they will have, right? Solubility table gives you this information. So, for example, let me Google it. I do not have it right now. So, solubility, solubility. table. Okay, solubility table like this, right? And you can see that there is we have it not that kind, maybe this kind, not that. Um, not. Oh, this kind of solubility table you have, I think, yeah. So, and you can see that there is ions with their charges here, and you can see chlorine, chloride, bromide, negatively charged. So use your solubility chart, okay? Okay. Soluble ionic compounds undergo dissociation reactions when they are in a solution or when they are melted, right? So, for example, iron 3 bromide solid with water. So, in water, it will be aqua, right? I would say that. It becomes aqua and gives us iron and bromine. And now we take a look at solubility table, right? And we can see that I lost it again. This one. We can see that bromine has negatively charged, one negative, right? So, and I'm going back here, one negative here. Subscript 3 shows us that there will be 3 bromine anions, right? That gives us 1, 2, 3 negative charges, okay? And we need 3 positive because the whole compound is neutral. One atom of iron here that gives us 1, 2, 3, 3 positive charge. Okay, this is dissociation for iron 3 bromide. The next one, potassium 3 PO4 potassium phosphate. Solid. When solid compound we put in water, it becomes aqua, and in this situation it dissociates, right? So potassium 3 potassium, and you know potassium it has only one possible charge, like one positive, that's all, and plus PO4. So if you don't have a chance to look at the periodic table, of course you don't have it, right? But you can figure it out from this. 3 potassium plus gives us 1, 2, 3. 3 plus total charge. And there's only one PO4 anion here that gives us 3 negative charge. 1, 2, 3. Okay, and please pay attention. You use digit before and then plus or minus. Okay. The next one, calcium chloride, aqua. Calcium 2 positive plus 2 chloride negative. Okay. The next one, lithium 2 SO4, lithium sulfate. It's soluble or 2, so aquatic, 2 lithium plus and together SO4 will be 2 negative, and it's just up to you guys. Train and try to think why it's 2 negative. Okay. Okay, single replacement reactions. One of the atoms become an ion, and another free element is released. For example, like zinc plus hydrochloric acid, and in your homework I saw that some of you named it in the wrong way. So hydrochloric acid forms zinc chloride and hydrogen gas, right? So zinc replaces hydrogen here. And during this reaction, neutral zinc, because it's an atom, right, becomes zinc ions, right? And hydrogen here is neutral hydrogens because it's hydrogen non-polar molecule, no charges at all, and here it is partially positive, right? And neutral zinc here, but here it's 2 plus because it's ionic compound. So and we will talk about this later. This is an example of reduction redox reactions. So, another example for single replacement reactions. When chlorine gas reacts with sodium bromide and chlorine replaces bromide. But this is not balanced. I need 2 here. Okay. What is this? This is a chart that shows us activity series for metals, right? So you can see there is some important parts in here, hydrogen here, right? And arrow shows us the way from bottom to the top. Topest metals substitute lowest metals out of their compounds, right? So, for example, let's do some example. Lead, Pb, and copper 2 nitrate. Let's find it. So, Pb is here, right? And copper is here. So, copper is less active than Pb. That means that Pb can substitute copper. Pb NO3 2 times the same, charge will be the same. How can I find it? Solubility table plus copper. Okay, the next one, copper and PbNO3 2 times, right? And you can see copper is less active, so it's not impossible. Copper and H2SO4. So, acids in a solution can react with metals, right? But with metals which are higher than oxygen in this line, right? So we can find hydrogen here, and hydrogen is upper than copper. That means that there is no reaction here. But if we have, for example, zinc, right, plus the same acid, sulfuric acid, aqua, we can find zinc here, right? So, yeah, it's here. And hydrogen is here. That means that reaction is possible. Zinc replaces hydrogen, SO4. For zinc, in a solubility chart, you can find its charge to positive and SO4 to negative, so we don't need to add any subscript here, right? And H2. Okay, and it's already balanced. Let's do the next one. Lithium plus, I do not like this example, I'm sorry, let me just, and you will please change it. Zinc plus iron SO4, iron 2 SO4. And I will explain you why I changed the metal. So zinc and iron. Zinc is more active, right? So that's why it replaces iron here. Zinc SO4 plus iron. Okay. Why you cannot use metals from potassium? Lithium will be here because the lithium is not in this chart, right? But from lithium to sodium, you cannot use these metals uh, for not replace metals out of uh, aqua. I mean, out of solutions, right? Because they react with water, and we will talk about that later. Double replacement reactions. So two compounds, like two dancing couples, and they switch partners, right? So three types of double replacement reactions: precipitation, neutralization, and gas forming. Terminology in U1. A precipitate is an unsoluble something substance, right, formed during a chemical reaction. For example, we have two solutions here, right? They are transparent. We don't see that something inside the water. So, but when they one solution add to another one, we immediately see the result that something is happening here. A precipitate. This is precipitate. A precipitate. Precipitate is an insoluble solid formed during a chemical reaction. Okay. Okay, so for precipitation, you need to use solubility table again. And let's do this one. Silver nitrate and sodium chloride. So I'm going to underline cations because cations will replace each other, right? So silver goes here and sodium goes here. So sodium nitrate. According to solubility table, we put charges sodium plus NO3 negative, right? So positive and negative charges are equal to each other, so no additional subscripts are needed here. And AgCl, so silver chloride plus and minus, so according to solubility table 2. And take a look and in solubility table, and you will see that I will try to zoom it, but maybe no. Remove. Okay, maybe no. View image. Maybe yeah, it's like this. Okay, so how do we use solubility table? So we have two compounds actually. We have sodium nitrate. So we found sodium plus here, right? And nitrate here, and do like cross lines here, right? So I'm going here when I meet this um, vertical group, and I can see the sign here, soluble. That means that this compound, sodium nitrate, is soluble, right? The second one we have is silver chloride. So I found chloride anion here, and I am moving my mouse toward silver ion. Oh, and I found that it's insoluble, right? So that means that it's precipitate, okay? And this arrow shows us that this will be solid. So aqua, right? And solid. Okay, another one. Copper SO4 and Na3PO4. So cations replace each other. So copper goes copper and PO4. And according to solubility table, I can found. So PO4, 3 negative, see? And for copper, it's 2 positive. You can see. So I'm putting charges here, 2 positive, 3 negative, and subscript will be 3, 3 here, and 2 here. Okay, sodium plus sodium and SO4. For sodium, it is plus, and for SO4, it's 2 negative. So plus and 2 negative gives us Na2SO4, right? And we need to balance it, the first of all. So copper 3 goes here, underline it, right? 3s, 1s at the right side, so 3 here, right? And count 3 by 2 sodium. I need 2 coefficient here, and 2 phosphorus here, so it should be balanced. We check with oxygen amount, so 3 times 4, 12 oxygen here, and 2 times 4, 8 oxygen here. Total 20 oxygens. So 2 times 4, 8 oxygens here, and 3 times 4, 12 oxygens here, total 20, so it is balanced. But now we need to find where is precipitate here, right? So it's copper phosphate and sodium sulfate. So sodium, and you can see for sodium all compounds are soluble, so that's not about sodium. Then we need to find what's about copper. So copper 2 positive, right? And I am finding PO4. Yes, is it? Yes, let's check it. I'm going to the left. Yes, it's PO4, 3 negative. And that was the sign that this compound is insoluble, right? Insoluble. So I'm just gonna clean up something here. Okay. And it will be solid right here and aqua here.